This is a Czech Aircraft Works Mermaid amphibian. It was designed in the early 2000s, and this particular one was completed as a ELSA kit in 2005, and I obtained it in 2008 and completed it, flew it in 2013. I've been working with it ever since. As designed, they had quite a bit of problems with keeping the airflow over the cabin from separating, and to that purpose, as you can see, they went to a lot of trouble. We went to a lot of trouble with vortex generators and to keep that over, keep the airflow flowing around the other side. And it works, but there still was a remaining problem with it, in that a subtle problem, but it was significant. And that was that on the river, when you're heavy and you attempt to lift off during takeoff, the aircraft would not lift off. It wouldn't get going fast enough, and it would just kind of stall back into the water. And so about 9 months ago, I decided to take a look at it, see if I could figure it out by Tuft testing the area here, and seeing if we could come up with a solution.
So here's the first version of the Tuft test. You can see the tufts on the inner portion of the wing. Also included is the first fence. And you can see that we initially had a few tufts on the other side, and that will be expanded. We used an SJ Cam camera, which is really handy because you can put it in different places. It's small, and also it's controlled with an app on your phone, so you can only record in the portion or the time that you want it to record. Really handy, recommend it. All right, here's the first shot without a fence. We're approaching a stall. You notice that there's quite a bit of turbulence at the rear inner part of the wing. And then as the airspeed slows, you can see that the stall progresses over the wing. Here is the same sequence, except from the rear. As you slow down, you see that the flow that's very disturbed at the rear root then expands out onto the wing and precipitates a stall over the wing. Notice the extreme outboard at the rear end of the where the tufts are. It's blowing from the back of the fuselage straight out the wing. And here's a shot at cruise. So even at cruise, you have quite a bit of disturbed air. All right, here's the first fence, and this is again showing an approach to a stall with the first fence. Notice on the forward, the leading edge, right at the inner portion, there's been some belief that, and I was concerned that separation here, but it doesn't appear to be really significant. It's some, but it's not as significant as the beginning from the rear. Notice that the flow up over the fence is vertical. Really disturbed air in that area. But the fence helped. The stall happened later than before. The same scenario. We're approaching a stall except shooting from the rear. And you can look several interesting things. You can see that the airflow over the cabin at the rear, at the top of it anyway, is pretty much attached, but it's the space in between that's really disturbed. And the fence slows the precipitation of the stall out onto the wing. Now we're going to do the same thing except with 10 degrees flaps. See if there's any significant difference in the flaps up or flaps down or at the other level. So this is stall at 10 degrees flaps. There it lets go. Recovers. Now we put down 20 degrees flaps, do the same thing. Then finally, down at 30 degrees flaps, again the stall. Notice again the vertical air going up over the fence. It's really dramatic, the amount of air that's right there. So withdrawing the flaps, raising the flaps, and recovering. And turning away to go home. So this was the first large fence that I built, hoping that maybe being higher and extending out the back would help significantly. And this is, again, approach to a stall. It improved, but not enough to make that a viable option. Here is the final version, less some of the tufts, but again an approach to a stall. Settled on one that was slightly lower and not quite as full length. So here is a view of the final configuration with all the tufts removed. So what do we conclude? It's a good airplane, but it does have some issues. There is some concern that the leading edge, there's a leading edge fillet that goes between the wing and the fuselage, that was tripping the air, and there is some indication there's a little bit of that shown on these. But the biggest problem that has not been resolved is the air going around that cabin area just simply will not conform, and it's difficult. Now the Russians, one version of this airplane was sold in Russia, and as you can see here, they have a much more elongated afterbody. And if where I were to continue development of this airplane, that's one of the places I'd go to try to really get the thing fixed at its core. In the meantime, the stall fences have done substantially improvement in the aircraft, and it lifts off the water now normally with 10 degrees flaps. I don't have to go to full flaps to be able to get it to rotate, and it's generally a much better behaved aircraft. So I hope you enjoyed this video. It shows what can be done with a little bit of Tuft testing and aeronautical experimentation. Thanks for watching.